We're here in the MOVP laboratory of Tyndall National Institute, where we produce our 3,5 materials, conventional 3,5 materials, arsenide-based and phosphorus-based. We're here specifically to highlight one of the offers on ASCENT Plus, which are pyramidal quantum dots. They are actually site-controlled quantum dots, and they are rather unique to Tyndall National Institute. You won't find another lab at the moment with the capability of producing them of the quality we have. They are interesting because they are also probably the only site-controlled quantum dot system which has proven to be on par with self-assembled quantum dots, which other groups in the world offer by molecular beam repeaters. Pyramidal quantum dots is just the name of the recess they're grown into, and one of the key features is that this system can be engineered to provide different properties. We don't have to make one single quantum dot. We can couple dots. We can stack many dots one on top of each other in a controllable way, and we have two families, one in the near infrared, let's say from 850 to 950 nanometer in terms of emission, and gallium arsenide dots which will emit within 720 and 800 nanometer. They've proven as very good entangled photon emitters, but obviously there is more to the system, and there is all applications that are now being explored in the community which are possible. It should be also said that while the ASCENT Plus offer encompasses pyramidal quantum dot design control unique to Tyndall, there is also a broader offer in ASCENT Plus, which is linked to the fact that we working every day on many conventional, for example, projects about conventional devices for telecommunication or red emitters and so on. So we grow in this machine routinely lasers, modulators, LEDs, detectors, and we also have developed a rather well-established metamorphic technology to extend the wavelength of 3,5 materials. So this is also part of the ASCENT Plus offer, and we are open to any submission of projects and collaborations which are aligned to the ASCENT mission or which would exploit these materials. We are here in the Quantum Optics lab at the Tyndall National Institute, which is the lab where we characterize our site-controlled pyramidal quantum dots, which characterize the ASCENT Plus offer. The laboratory is equipped with everything is needed to prove the quantum nature of the light emitted by the single or stacked or multiple quantum dots that we produce in the MOVP laboratory. We have 10 Kelvin or lower than 10 Kelvin, 6 Kelvin cryostats to cool down at the temperature needed. We have a correlation spectroscopy set up, lasers to pump and resonant pump the dots so that we can fully characterize them before we ship them, and we can, we're sure that the quality of our work is, which we promise, is met.